Hey everybody, a little job for you before we get started today. Something to think about first. What kind of correlation do you see here? And what would the line of best fit look like? Pause here, decide that for yourself. You ready to go? Unpause. Okay, hold that thought. I'm going to come back to this. Today I want to teach you just what you tried to do. I'm going to teach you how to deal with lines of best fit when there is an outlier. So if you'll take a moment and title your next free math page as such, and then mark it and unpause when you are ready to go and at maximum concentration. All right, so we've been talking about correlations and lines of best fit in scatter plots for some time now. There can be positive correlations. That means the line of best fit would have a positive slope. There can be negative correlations. That would mean the line of best fit has a negative slope. And then there are situations with there's no correlation at all. And I just a moment ago asked you to consider that question for this graph here. And I chose that one specifically because I think outliers can make it really hard to identify correlations sometimes. When I look at this graph, my first instinct to say is there's no correlation between the variables. I don't see a particular pattern. Doesn't look like the size of the class and the number of absences in these cases really have anything to do with each other. I can't necessarily invent one. I can't necessarily come up with a correlation, like why they would be related. And outliers can do that. There is an outlier here, and that makes this graph look very uncorrelated, pretty random. However, sometimes if I take this graph and I ignore that outlier and say, that's a clear outlier, nowhere close to the rest. If I ignore that one point, it all of a sudden looks like a whole new graph to me. And I actually do see a correlation. Not a super strong one, but if I just ignore one point, I do feel like, I would probably place a line of best fit somewhere like that. I do think you see a negative correlation if you ignore one certain point. These kind of trend down. It gets a little tighter even if you ignore certain other outliers, like that's probably one. And then that makes the correlation even more clear if we kind of take outliers out of the picture. And that's really what I want to teach you today is in some cases, if you see an outlier, try re-looking at the graph without it. And then make your line of best fit without the outlier. I think that's the best way. It kind of only respects the ones that fit the pattern, which kind of makes sense to me. And just say, well, this isn't how this usually works, and this isn't how this usually works. So I'm just not going to include them. And I think that that's the best thing to do. So there are times when there's no correlation. I don't want you to think that, well, if there's no correlation, you just have to X out points until there is one. But I do think if you kind of go back and look at this when it's blank, it really looks like no correlation. But if you start, it's an outlier, all of a sudden 1 point gone, and it tells a different story. So make your line of best fit sometimes by just totally ignoring the outlier. When you do that, if you're presenting this to somebody, make sure you tell somebody that you did that. If you have software make your line of best fit for you, or it actually calculates the mathematical way to make it, which we're not going to learn, it will skew your line of best fit. It has to include it. It has to respect it in the formula. Whereas if it takes it out, it would tighten it. We're going to do it more like that and just kind of pretend that that one wasn't there. So just when you do that, make sure you tell your reader you did so. So if I come back here and I say I made that line of best fit, make sure to give your reader a little point that said I excluded the outlier in this case. I think that that's the best thing to do. Just make sure your reader knows that you did it. I think it's fair. Let's try one together. So this one even kind of shows you the outliers. If you are asked to draw a line of best fit here, and let me do a little magic work here and kind of just make these into regular points. I think if you saw this graph with these extra 2 points there, that little change alone makes it look like I don't remember exactly, it was somewhere around there and somewhere in here. Just adding those 2 points really, to me, makes it look like there's no correlation. Like when I stop and look, it looks very random. And I think it's just wild that just getting rid of 2 points changes the entire way that that graph looks to my brain. So if I were asked to draw a line of best fit in this situation, before I rush to judgment and say there's no correlation, which there might not be, there's nothing wrong with saying that if that's truly the case, but stop at these graphs again and look, what would they look like without those? And I think now, if I exclude those 2 points, I definitely see a correlation. I do think that there's a, generally speaking, height and weight seem to be correlated. The taller someone or something is, the more that it weighs. And that makes sense to me anyway. You know, sometimes that's my way to do it too. I kind of think, should I see a correlation here? And if I don't, I kind of get rid of my outliers and make sure I see one. Last thing to know, of course, please also tell your reader that you did that. So if you're presenting this problem to a teacher, doing it on a test or something, just say, you know, I excluded the outliers to make it more accurate. I just think that telling them that lets them know that you did that and kind of makes a lot of sense. And you see it. That's it, y'all. It was a quick one today. Hope that made a lot of sense to you, and we will brush up on it again when I see you tomorrow.